Welcome back to Algebra 2, Chapter 13, Section 1. This is our last full chapter we're going to do. It's about trig. If you have not had any trig at all, if you skipped geometry and went straight from Algebra 1 to Algebra 2, I would advise you go find on my YouTube channel, go find geometry where I teach trig. And go watch it first, because I'm going to kind of assume you know it and kind of go fast, and you might not know it. I've often had Algebra 2 kids who skipped geometry and went straight to Algebra 2, and I remember one fellow last year, I started talking about all of this stuff like, of course you know this, and his eyes just got bigger and bigger and bigger. I was like, you've never had this, have you? Alright, so we're going to first talk about right triangle trigonometry, which you learned in geometry, and then later in the chapter we're going to talk about what if it's not a right triangle. So remember, a right triangle is marked by this, and it means one corner is 90 degrees. And you have the longest side, which is called C, and it's the hypotenuse, and then you have two shorter sides that are called legs. And you can, if you have two of the three sides, you can get the other one through the Pythagorean Theorem. A squared plus b squared is c squared. And I have two programs on my calculator. One says Pythagorean Theorem, and it finds the hypotenuse, and I have another one called find leg. And if you have one side and the hypotenuse, it'll give you the leg. I say do your calculator. The other thing is when we start doing trig, you need to make sure your calculator is in degrees, not radians. That's found under the mode button, which is right up there next to second. Okay, so now how does the trig work? Okay, so now when we talk about angles, we don't call them, they're unknown. We don't call them x. We call them the Greek letter theta. Don't we feel very smart and clever knowing that? Okay, so this is theta. The longest side of the triangle, no matter what, is still the hypotenuse. But the theta can change, or unknown angle. It could be that one or that one. The other one's known, it's 90, but either of these two are candidates for theta. But I said this one's my theta. This angle that is straight across from it, like if this was a trumpet, is called the opposite. The angle that's next to it, not the angle, the side. The side straight across from it is the opposite. The side next to it is called adjacent. You hear about an adjacent lot. That means a lot, some yard, that is next to something. Now notice the hypotenuse is also next to theta, but it's not the adjacent, it's the hypotenuse. So there'll be two things that's next to it. The one that's not the hypotenuse is called the adjacent. These are your trig rules, okay? And there's different ways you can remember it, but I have found that students remember it the best with this way. Okay, get ready. Imagine the barnyard drama, okay? Some old horse, are you imagining the horse? Way back, old. Caught another horse. The alarm. Taking oats away. The thief. So we have two horses, the thief horse, the old horse, and what was going on, the catching of the thievery, of the oats. So some old horse caught another horse taking oats away. Some books will say, so-ka-toa. But then I have kids saying, okay, what are the trig rules? And they go, it sounds like an Indian word. Or it has something to do with toes. The horses work better. Some old horse caught another horse taking oats away. So those are your main trig rules. Now, you can also flip them upside down. This is one of the things that's hard to remember, and when they put me in charge of math, I'm going to change it when I'm queen of math. I don't know how I'm going to get this, but I'm running for it. Okay, so tangent makes sense. If you take the tangent and flip it upside down, putting the numerator on the denominator and the denominator on the numerator, then it's the cotangent. So co means flip it upside down. Okay, that one makes sense. But the problem is cosine already has a co, so it has to be something else. So they call it the secant. So if you take cosine and flip it upside down, it's the secant. It would make sense if cosine was sine flipped upside down, but it's not. So instead they made sine flipped upside down the cosecant. It makes no sense. I'm going to rename them. Tangent, cotangent, this will be called secant. It'll mess up the barnyard thing, but we'll figure out a new one. And then that would be called cosine, and then this would be, this would be cosecant, and then that one would be sine and cosine. But no, can't do that. We're going to have to stick to the other one. Some old horse got another horse taking oats away. If you flip it, it's cosecant, secant, and cotangent, and those are all the theta. If this makes no sense, do not worry. In just a second it will. Okay? So what is this good for? I don't want to hear what you said. Okay, what is this good for? It's that here I have a triangle, and I can, over here, let's go to this one, okay? Here is a triangle. I only know one side and one angle. By using my trig rules, just these, some old horse caught another horse taking notes away, I can figure out every side and every angle. That's what it's good for. Before, we would have had to have known 2 angles to get the third, because we know, where did I write it down? That, I don't know where I wrote it down. Remember that the 3 angles of a triangle add up to 180. So if we have 2, we can subtract from 180 and get the third one. And if we had 2 sides, we could use Pythagorean Theorem and figure out the missing third side. But we can figure out everything with trig with 1 side and 1 angle. You see how great that is? Okay, so now, remember in algebra, when you very first started solving equations, they didn't let you solve it. They made you do a test point first. And I told you, nobody does this in real life. In real life, you solve for x. None of this baby stuff. Well, they're starting you on baby stuff. Okay, so this is it. I have a triangle, and I am told that one side is 3, one's 4, and I have a theta, okay? I can find my other side. If I have 2 sides, I can find the other one by the Pythagorean Theorem. And 3 squared plus 4 squared is 9 plus 16, which is 25, square root it, and it's 5. So just using Pythagorean Theorem, I can figure out what the 3 sides are. But what they want me to do is they want me to substitute these sides in to the formula. So, some old horse. So the sine of theta is the opposite over the horse, the hypotenuse. Caught another horse. The cosine of theta is the adjacent over the hypotenuse, taking oats away. The tangent of theta is the opposite oats over the adjacent. Then they wanted us to do the inverses, so you just flip them. Cosecant is 5/4, secant is 5/3, cotangent is 3/4. Now, in real life, we don't do this. This is baby. Nobody does this. There's no point in doing this. The reason why you do it is so you can solve for theta. So in real life, I would do on my calculator second sine. It'll put this little thing where it looks like sin to the -1. And then I put this in here, 4/5. And I hit equals, and it will tell me that theta is about 53 degrees. I could do it with cosine. I could do inverse cosine, second cosine, it'll say cos to the -1. Put in 3/5, and it'll say 53. I could do tangent. I would do second tangent, it'll say tan to the -1, I put 4/3, I hit enter, and it'll say that theta is 53 degrees. There's no point in doing these except to figure out what theta is. And once I get the theta is 53, then I can do 180 minus 90 minus 53, and I can get the other one. And that is called solving the triangle, when you know all the sides and all the angles. Okay, the next thing in your book is this little chart. A long time ago, people did not have these calculators. And so instead they had to, and this was before my time, the moms of kids I teach who are just a little older than me, they have done this, but I'm too young. I know, you're like, you're too young for anything? Yes, I know, it's exciting. Anyway, they use this thing called a slide rule. And you would slide these little bits back and forth, and you could figure out, kinda, it was not real accurate, you could sort of figure out what your calculator does with the sine, cosine, and tangent buttons. So the teachers wanted to teach this to kids, but they really couldn't rely on those rulers, so they decided that the common triangles are 30, 60, 90 triangles and 45, 45, 90 triangles, and they made them memorize the values for sine, cosine, tangent for the common triangles. Common in quotes. They're not really common. It was just so you didn't have to use a calculator. I think it's pointless now. We've had these calculators all of my math career, and I'm old. So I don't make you memorize them, but I have boys in college and their teachers still have been making them memorize it. But I'll let you do that in college. You don't have to do it now because I think it's dumb. We've got calculators. Okay, so the common triangles. The other thing you can do is you could look them up in books. I saw the books when I was in college, never used one of those books, never once. All right, so here is a problem. We are given one side, the hypotenuse is 10, and we're given the theta is 60. And we want to know what is the opposite. So we go over here and say, which one has opposite and hypotenuse? It's some old horse. So we fill it in. Sine of theta is x opposite over hypotenuse. Now we just say, why is x not alone? Because it is being divided by a 10. So what's the opposite? Multiply by 10. What I do to one side, I do to the other. So theta equals 10 times sine of theta, which is 10 times sine of 60. You can type it in your calculator exactly like that. You don't have to hit times. Just do 10 sine 60, and you get that this side is about 8.66. If I wanted this side, this one is the adjacent. So which one has adjacent and hypotenuse? That's cosine. So I would do cosine 60 adjacent over 10. I would multiply both sides by 10. On my calculator, it would be 10 cosine 60, and this side is 5. I could get the angle because all three angles equal 180, so that if this is